Hello everybody, and welcome to the next video on two-dimensional vectors, also known as tables. So the last video was an introduction to tables, so we talked about how you declare them and how you print them and things like this, but we didn't do much with them. So in this video we're going to start doing things with them. In particular, in this video we will do three things. I want to start by just talking about how you format the output. So if you remember last time, we didn't have the columns lined up properly when we printed, so I just want to fix that real fast. Then I just want to talk about how you can get the entries from a user, so have the user enter things into the matrix. And then we'll do two examples. So we'll talk about how you calculate the transpose of a table. If you don't know what that means, that's fine. I will define it for you. And then we'll get sort of a Sudoku program sort of up and running. So it will just be a skeletal program, but you'll get the idea. Okay, so first, if you want to line up the columns of a matrix or a table or a two-dimensional vector, whatever, there's a really easy way to do it. So let me just recall for you our issue from last time. Here's the table from last time. When you print it, it doesn't look very nice because the columns aren't lined up. If you want to make sure that the columns print lined up, you just need another library, IOmanip, that stands for Input-Output Manipulation. And then, as it says here in the slide, you need a command called set W and then N. So set stands for set, W stands for width, and N is the number of characters you want in a given column. So if N is 3, that means that you will print 3 characters. So in this case, I would print a 1 and then 2 spaces, a 2 and 2 spaces. In this case here, I would print a 1, 1 and then a space. 1, 2, then a space. Okay, but the idea is that whatever this N is, that's setting the width of a given column. So all of the columns will have the same width so that when I display it, it looks nice. So the way that I will use that set W command is I will put it right here before I print anything, set W, and then maybe I just want 4 spaces. Okay, so now every time you print an entry of a table, you're forcing it to print 4 characters. So it will print like an 8-2 and then 2 spaces, or 101 space, whatever. But the idea is that the spacing is now uniform. So when you print, this is what it looks like now. All right, so it's right justified. If you don't like that, I'm not sure how to change that off the top of my head, but notice they're all lined up now, right? So it looks nicer. So if you want to print things that look nicer, print tables that look nicer, it's just an easy fix. It's like this. Now, the bigger you make that number in there, the more spacing you're adding. So at some point, it will just look kind of stupid. I mean, this still looks fine, I guess, right? But it's more spaced out because I upped that number. Okay, so that's how you can get a table to look nice when you print it to the screen. Next, let's get the input from the user. So this table here, I set it up, right? This is the table from the previous video, so you've already seen this code. But I went through and I just forced these entries in there, right? I coded them according to this formula. Suppose you want to let the user enter a table. Okay. You might not even know ahead of time how many entries there are. So first, we'll have to ask the user for how many rows and columns there are. Let's make this short. So just prompt them to tell you the dimensions of the table. Okay, so once you have that data, then rows goes right there. Columns goes right there. And then you take that same for loop structure that we've done plenty of times now, and you just, instead of like printing or whatever, all you're going to do is grab that entry from the user. So you're going to start at row 0 and then go up to the number of rows. Something happened here. Boom. Okay. And then you're going to go column by column and just grab things. Okay, so then all you're going to do is just grab from the user whatever entry they want to have at that spot. So I'm not going to add things just to save time here, but if you were doing this for real, you might want to have a command here that's like something like this. Like, give me the entry at row, and then just tell them the row you're at, and column. Right, so just tell them where you are, right? So that tells the user how you're marching through the table. The way I set this up, you're marching row by row, and then once you're done with a row, you move on to the next row. So you're inside a row, and then you go column by column, I guess is the way I should say it. But you fix a row first, then just go entry by entry inside that row, and then when you're done with the row, you move on to the next one. Okay, so let's just make sure this works. Okay, so now that I have the table, let me just print it using the same nested for loop printing structure we've had before. So what's going to happen here? You're going to grab the entries from the user, and then you'll tell them, like, here you go, man, here's what you gave me. So we're just going to confirm that it works. So I don't want to do anything too big, so I'll do 2 rows, 3 columns. So give me the entries, like, I don't know, 1, 2, 3, 4, 5, 6. And it says, here's your table, man, right? 1, 2, 3, 4, 5, 6. Exactly what I put in. So all of that to say, if you want to let the user set up a table for you, here's the easiest way to do it. This nested for loop structure that I just basically copied from the printing for loops, but instead of printing the entries, you don't have any entries yet, so you grab them from the user as you go. Okay, so now we know how to format the printing of a table if we want to. We know how to get entries from a user if we want to. Let me now do 2 examples for you. These examples, they're not chosen to illustrate any particular technique or anything. They are just chosen to get you more comfortable with tables. So both of these sort of show off how you can mess around with tables. Okay, so first I need to define for you what a transpose is. We're going to write a program that calculates the transpose of a table. So if A is a table, the transpose of A is obtained by making every row of A into a column. So basically what you are doing is you are swapping the roles of rows and columns. So if here's your original table, you have 2 rows and 3 columns. What you're going to do is make this first row into the first column here, right? 2, 4, 8 becomes 2, 4, 8 column. Then make the second row into the second column. So that's what a transpose is. Row I, what used to be row I, is now column I. Okay, that's what a transpose is. So let's go back here to the code and let's write, okay. So let's write a program that does that for us. So we've already grabbed a matrix from the user here. So let me just keep all of that. And then let me also just print back to the user what they gave us. Okay, so I'm going to keep all of this structure here. Now I want to add to this a transpose matrix or transpose table, whatever word you want to use here. So if I come back here to this example, this was a 2 by 3 table, 2 rows, 3 columns. The transpose has 3 columns, 2 rows. Okay, so a 2 by 3 became a 3 by 2. So when you swap the roles of rows and columns, you also swap the dimensions. If you used to have 2 rows and 3 columns, now it's vice versa, right? It's the other way, 3 and 2. So back here, if I want to create my transpose, now let me just copy and paste this. So let me just call it transpose. Okay, so now when I define its size, the rows and columns have switched. All right, so if this number of rows was a 2 and this number of columns was a 3, now you have a table that's 3 by 2. Okay, so now let's talk through, given this matrix right here, given this table here, how would you compute the transpose? Well, notice this 4. This 4 is at position, what? 0, 1. It's in row 0, column 1. Where does the 4 go down here? It goes to row 1, column 0. So its position used to be 0, 1. Its new position is 1, 0. So when you swap rows and columns, all you're doing is swapping the location data. So again, if you want to know where you are inside of a table, it takes two numbers, a row number and a column number. If you swap rows and columns, you are simply swapping those two numbers. So by the same token, 8, that's at position 0, 2. Now it's at position 2, 0. So I can exploit that fact to my advantage when I build the transpose table. Okay, so right here it says, here's your table, blah, 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 right? So now let me take this for loop structure and let me build a transpose from it. So let me just recap where we are in the code. So far, the user has given me a table. Here's the nested for loop structure to get the table from the user, right? You are inputting the table. Then I will just print that table back to them just to make sure that they gave me the table they wanted. What I'm going to do next is calculate a transpose. So what does that look like? Well, the transpose so far, where did I declare it? Declared it right here. Transpose so far, oops, that shouldn't be there. The transpose so far has nothing in it. I've declared it, but I haven't filled in any of the entries yet. So how do I build the entries? Well, I'm just going to go row by row, entry by entry, and fill them in. Okay, so what should the entry of the transpose be at row I, column J? Well, that entry should be whatever was in row J, column I, in the original table. Okay, let me just talk through that again. What is the transpose? The transpose is gotten from my table, the original matrix, from swapping the rows, the roles. I have a lot of trouble saying that. By swapping what the rows and columns are doing. So this J number here, if that used to be a column number or a row number, it should now be a column number. This I number here, if it used to be a column number, it should now be a row number. So all we're doing is we're just going back to the original table and swapping first coordinate and second coordinate. So once we're done, let me just take all of this. Say here's the transpose. And instead of printing my table, I will print the transpose. Okay, let's run this. This code will be on Moodle, so you can play with this if you want to. So I want to do a 2 by 3 table at first. I'm going to type 2, 4, 8, and then what? 1, 3, 9. It says, here's the table. Whoop. Did not print the transpose. Why is that? Oh, okay. So I made a mistake here. Can you see what the mistake is? So here's where I create the original table, right? I is keeping track of row number, right? Row 0, row 2, row 3, whatever. J is keeping track of column number. But if you're going to swap rows and columns, you of course must do that here too. So when you're creating the transpose, right, you have to swap rows and columns. So now, when you're going back to the original table, you have to respect that you've done this, right, that you've swapped. And I did not make this mistake when I set up the declaration, right? So where's the declaration? Declaration is right here. Columns, rows, right? Things have swapped. Okay, so let's see if that's my only mistake or not. 3 rows, no, 2 rows, 3 columns, 2, 4, 8, 1, 3, 9. Yeah, okay, good. So there's the original table, there's the transpose. So again, not to just beat a dead horse here, but when you're going from the old table to the new one, if you swap rows and columns, you have to swap them everywhere, not just where you feel like swapping them. Okay, so I hadn't swapped them everywhere. You have to swap them when you're building the transpose, and you have to swap them when you're printing the transpose, both times. But in any case, now you can see, here's the table, here's the transpose, so it worked. So that's one thing you can do with the tables. And notice this line of code here is the key line of code, right? I'm going to build the transpose at position ij by just pulling the entry from the old table where the coordinates are switched. And I need to do that everywhere. So I have to go through the table of the transpose one entry at a time using the nested for loop structure as we've been doing. And at every single step, I'm just pulling a swapped entry from the old table. Okay, so with this now correct, let me just save this so that I can put it on Moodle for you when I'm done. Okay, so to close this video, let me show you how you might start, if you wanted to build, start building a Sudoku program. So first, let me just remind you or tell you of the rules of Sudoku. A Sudoku board looks something like this. It's a 9x9 grid that has been broken down into sub 3x3 grids, as shown here. And the rules of the game are simple. Inside of each sub 3x3 grid, so here, 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 etc., inside of each of those subgrids, you can only use the numbers 1 through 9, and you can only use each number once. So like in this grid here, this 3x3, 7 has already been used, so no other 7s appear here. In this grid here, 9 has already been used, so no other 9s inside of here. That's the first rule. The second rule is you can never have the same number twice inside of a single row. So this row here, this row of length 9, there's already a 7 there, so no more 7s. There's already a 6, no more 6s. So this entry right here, you might want to write a 7 there because there's no 7 inside this 3x3 grid. But you can't put a 7 there because there's already a 7 in the row. Okay, so first rule is inside of a sub 3x3 grid like this one, this one, this one, this one, this one, etc., right? These thicker things here. You can only use a single number once. Inside of each row, you can only use a single number once. Also, the last rule, inside of each column, only a single number once. Okay, so like in this 3x3 grid here, there's no 7 here. But you can't put a 7 here, here, or here, because there's already a 7 in the column from up here. So when you play this game, basically it's up to you to fill this table in just respecting those rules. So eventually this table will be filled in. This row right here, you're going to have to put a 1 in there, a 2 in there, a 3 in there, a 4 in there, a 5 in there. No 6, because 6 is already written. No 7, 8, 9. But whatever that 9 you write down can't be right here. Whoa. Wow, I didn't know that could happen. What's happening right now? All right, well, anyway, you can't put a 9 right there because there's already a 9 in the column. Can't put a 7 right there because there's already a 7 in the column. Man, this is amazing. I had no idea I could check mark this thing. Okay. Well, anyway, so those are the rules of Sudoku. So a given board will look different. This was just a sample board I found on the internet. There are all sorts of other start configurations you could have here. In the interest of time, let me just find it. I have already, oh, right here, already created that board. Okay, so let me just walk you. This code also will be on Moodle, by the way, so you can play with this if you want to. So let me just walk you through what I did. The table is 9x9, right? So I created a 9x9 table. I then just put zeros everywhere because if you want to store in C++, if you want to store data like this, numeric data, a blank space is not a number. So I'm just going to use 0 to denote blank space. and then I just went through one at a time and added the numbers that are supposed to be there. So like at position 0, 5, there's supposed to be a 6 there. At position 0, 7, there's supposed to be a 7 there. At position, 1, 1, there's supposed to be a 7, etc. So basically all I'm saying to you is that I preloaded this board that I'm showing you, and here's what it looks like when I print it. Here's what it looks like just on in the regular Sudoku board. So a blank space over here is a 0 over here. But anyway, like the second to last row, right? Blank 3, blank 5, blank 8, blank 9. That's in there already. Okay, so now if we want to play Sudoku, what do we need to do with this board in place? Well, we have to just keep playing until this table is filled in. So this table here, right? So what does that mean? That means you have to keep playing until the zeros are gone. So I've used the word until, right? So that means there's going to be a loop. So we have to set up a loop that lets us just keep choosing entries and filling numbers in until the zeros are gone. I've created a variable that lets me do that called entries left to fill in. And initially that's true because I'm not done yet. So way down here, let me actually start gameplay. So while entries left to fill in. As long as that's true, I should play. Let me just make sure that entries left to fill in. Okay. Okay, well, how does gameplay go? Well, gameplay goes by letting the user choose a location of the board and put a number there. So we should probably create variables that lets the user do that. So we need to let the user tell us where they want to put something. So they have to tell us a row number and a column number, and then we have to let them tell us what they want to put there. So let's go add all that here. So we ask the user which row, and then get it from them. So this is not going to be a fancy program, right? This is bare bones. Which column? So I'm not making the output super nice or anything. Although perhaps I should add new lines. Just and then, just like with other programs, oops, I'm sorry, double equals there. Just like with other programs, if they chose a location where a number is already filled in, we may want to tell them not to do that. So you can add this or not, it doesn't matter. But while Sudoku table row column, if that's not equal to 0, maybe we should force them to choose again. You know, you don't have to do that, but if you want to make it so that they can't overwrite numbers, like, for example, this 7, we probably shouldn't let them change that because that was part of the original board. If you were writing this game for real, I suppose that, like, if they put a 2 right here, you may want to let them erase that if they want to. So if you were writing this program for real, you would keep track of which numbers are original to the board and which numbers they have added. Okay, but we don't have time for that now. So we'll assume that once they've written a number down, they're going to leave it down. Okay, anyway, so once they've chosen a legitimate spot, then we say, entry, like, what do you want to put there, man? And we get that from them. And so then what should happen? At the location they gave us, that should become entry now. Okay, so what we've done is we've let the user tell us where they want to put something and then what they want to put there. So now, you know, what we should do is check to see if the game is over. And the way that we know the game is over in this case, I guess, is that all the zeros are gone. So how could we check something like that? How could we check if all the zeros are gone? Well, you can do this cute little trick like this. First of all, what's my variable that keeps going? Okay, entries left to fill. I'm going to set that to false. Entries left to fill. Oops, left to fill in. I'm going to set that to false. Then I'm going to search through the table entry by entry like this. I equals 0, I less than, I guess it's 9 by 9, right? So I less than 10, sorry, I less than 9, right? So we go 0 through 8. And same thing for the columns. Okay, and then if what we're currently looking at, let me write that, Sudoku table. If what we are currently looking at is a 0, so if we find a 0 anywhere, that means the game needs to keep going. So I'm going to reset that variable to true, and then the loop won't break. Okay, so what's happening here? First, I sort of assume the game's over, like I set this variable to false, the game's over. Then I search for any 0 at all inside the table. If I see a single 0, I will enter this if statement, and I will reset this variable here back to true. So the loop will keep running. Okay, so we're not done yet, but we're almost done with this video because I'm going to let you fill in the rest in class. Let's just run this to see what we think about this. So it gives me the table. Maybe I want to put like a 1 up here in the top left. So I'm going to say top left, which entry, like what do you want to put there? I'm going to put a 1 there, Oh. And then I should probably, at the end of the loop, I should probably have it print the table, just so I can see that it's doing what I want every time. Let me restart. So which row, 0, which column, I'll put a 1 there. And look, there's a 1 there now, it did it. Okay, so maybe now row 0, but column 0, I want to put a 2 there. And look, it did it. There's a 2 there now. That wasn't there before. There used to be a 0. So anyway, the Sudoku program is up and running in the sense that I can start filling in the table. What's missing from this program, of course, is a way to check that the user wins. So what does it mean to win? It means that you filled the table out, but not only did you complete the table by just filling in numbers, but you respected those rules of a single 7 in each row, a single 7 in each column, a single 7 in each of those 3 by 3 little subgrids, like this one here. So in class, what you will do is you will take this code and finish it, which simply means once the user's filled in the table, you're going to check to see if they won or not, if they abided by those rules. Okay, so at the end of this video, hopefully you were just more comfortable with tables in general. We will do one more video on these tables, simply because they are hard, and to show you some more examples, but that's all for now.